Section 2.1 is about frequency distributions in the graphs. And one of the big benefits of using frequency distributions in the graphs is it makes patterns from the data more evident and easier to spot as compared to just looking at the raw data. So in this video, I'm going to work through the main examples from 2.1 and show how to completely fill in a chart like this where we're getting the frequency distribution, also relative frequency, cumulative frequency, and then translating that into a histogram or a graph of the frequency. So a frequency distribution, we're just going to count how much data falls into each of the classes or each of the groups that we create. So it's a counting game. But before we can begin, we have to know what our different groups are, what our different classes are. So to determine our classes, we're going to look directly at the data, and we need to find the minimum or the smallest value, and we need to also identify the largest value. And then subtract those two to get the range. So from the smallest to the biggest is a total of 275. Now once you have that range, you divide by the number of classes to get your class width. How many classes are there? It's dependent upon the problem. So depending on the situation that we're in, it depends how many classes we want to have. This particular problem says that we have 7 classes, that we want 7 classes. So we're going to divide our range by 7. And we always want to then round up to the next whole number. So we're going to round up to 40. And that is our class width for this particular problem. So after calculating the class width, you can begin to create all of the classes that you're going to be splitting your data up into. So the first class, its lower limit is going to be the smallest value from your data set. The lower limit of the next class is found by adding the class width to the lower limit from the previous class. So if we add 40 to that, so 65 plus 40, we get 105. And then we continue that process to get all of the class lower limits. Now, these are all the lower limits, so the upper limit of the first class has to be 104. This range of numbers is going to be 65 up to 104, and I know it has to be 104 because the next class starts at 105, so 104 is the upper cutoff. This next one's going to stop at 144 for its upper limit, again because the next class starts at 145. The previous class has to stop at 144. So fill all those in following that same pattern. You'll also notice that you could, once you have the first one, that same process of adding the class width, adding 40 gives you what the next upper limit should be. And so we're actually going to use that on the very last step. This last class should run from 305 to 344 because 304 plus 40 gives me the final upper limit. So at this point now we just look at the data and count. Go one by one, be organized so you don't skip over any of the data or count anything twice. Cross it out once you've found what class it fits in. But you're really just going to be keeping tallies of how many pieces of data fall into each of the classes. And whatever your tally is, that's the frequency associated with that class. It's how many pieces of data are within that class. So after you've counted all your data and seen what's the frequency for each of the classes, how many are in each class, a good check that you want to do is to sum up all your frequencies and make sure they equal the total amount of data. Now, there were 30 pieces of data originally, so you could add all these numbers up and they should equal 30. There's an Excel function for that, equals sum, and then open the parentheses, select your data, close the parentheses. That will sum up all the data you selected, and it does equal 30. So that's a good check that we haven't overlooked any of our data when we counted our frequencies. And the next thing we'll want to calculate is our relative frequency. And what relative frequency is we're going to look at each class and see the frequency in that class. How big is that relative to the total number of pieces of data there are? So there are 6 things in our first class. What's the proportion that is, or the percentage that is, out of the total 30? So to calculate that, for each class, you're going to do the number in it and then divide by 30 every time. So for our first class, it would have a relative frequency of 0.20 or 20%. Now I did that in this column because I'm going to show the shortcut here in Excel. We're going to want to do C6, so reference that cell, C6, and then we're going to divide it by 30. So we get that same result, but now we can just drag down here, and what it's going to do is look, this one was C6, this one looks at C7, C8, and so on, and divides them all by 30, so it saves a little bit of time. Let's make all these have 2 decimal spots, and there are our relative frequencies for our classes. Now the check you want to do at this point is that your relative frequencies, their proportions or percentages, those should always add up to 100%, or if we're looking at them as decimals, it should add up to 1. So again, do a sum of all these values. And in Excel, if you use the formula, select the data, this should equal 1 when you hit enter. And it does, so that's a check that my relative frequencies are all accounted for. The next thing we're going to want to calculate is our cumulative frequencies. So what this is if we keep looking from class to class to class and keep adding up or accumulating how many total we have as we continue to progress through the classes. So after you look at the first class, there's 6. Now after you've gone through the first and second class, there's 6 plus 9, which is 15. After you've gone through the first 3 classes, there's that 15 plus 6 more, which is 21. Add 4 more is 25. 2 more is 27, and so on. And you should, when you're done with this, again have the total there is, because you've accumulated all the data from all the classes by the time you reach your final class. So what this is useful for is, if you were looking at your classes, you could say 27 pieces of data are at this class level or below. 21 pieces of data are at this class level or below. So it gives you, looking at that particular class or anything less than it, you know the sum of all the data pieces that are at that level or below it. Now as we transition to graphing these frequencies in either histograms or ogives, we're going to want to know the midpoint of our classes. So the midpoint is right in the middle. It's going to be the average of the upper and lower limit. And if you think about averages, you sum up your values and divide by how many you have. So you would want to add 65 plus 104 and divide by 2. Now in Excel, save yourself some time. If you do A6 plus B6, put that in parentheses so that we're going to take that whole sum and then divide that entire sum by 2. That'll give us the midpoint of the first class, and it saves time then because you can just drag it down and it'll give you the midpoint of all the further classes as well. Once again, notice that class width of 40, there's a 40 difference in between all of the midpoints. So we've gone through how to get the entire table for frequency distributions. Now first let's look at drawing the histogram for this particular frequency distribution. So what is a histogram? It's a bar graph basically for our frequency distribution. It has a few special properties, and one of them is that consecutive bars must touch, because we really don't want there to be gaps in our data. So by touching the bars, it's symbolizing that all the data values are accounted for. So to make the bars actually touch, we have to adjust our class boundaries as we're drawing the histogram for these classes, and it's an easy adjustment. You just subtract 5 from the lower, or 0.5, subtract 0.5 from the lower limit and add 0.5 to the upper limit. And you'll see your class boundaries then are adjusted like this. And notice we have the same exact numbers here then for the lower limit of our second class and the upper limit of our first class, and so on. And that's what makes our histogram then actually have touching bars, is because we've and it's shown better in this second one here, with these class limits adjusted by 0.5, our histogram bars will actually touch. The class limits are what go along the x-axis, or our horizontal axis here on the bottom. And then the height of each bar of our histogram is determined by the frequency in each of those. And so just draw it as high as the count from each class was. These two graphs are showing the exact same thing. So there's two alternatives. Sometimes you label the bottom with the class limits, or you can use that midpoint we found. So in this first histogram here, we're using the midpoint to label our horizontal x-axis here. Now notice the shape of this histogram. We're going to show the relative frequency histogram next, and it's going to have the exact same shape. The difference though is in our just plain frequency histogram, the y-axis or the vertical axis is the actual count from each of the different classes. When we show the relative frequency, that's going to be the relative frequency or the percentage from each of the classes. So on the next page, let's look at that. And so with relative frequency, the shape is exactly the same, but notice the different units here because we're measuring the percentage or proportion from each class as opposed to the actual frequency or count. And the last thing to look at is graphing our cumulative frequency, and that's called the ogive. And that's where, so just refer to our cumulative frequency column. We're just going to graph the number, how many there are after we reach each consecutive class. So after the first class, there were 6. After the next class, there was 9 more, so we're up to 15 and so on. And it just looks kind of like a line graph here. And it's called an ogive. It's graphing the cumulative frequency of our distribution.